Welcome to Science Access. In today's class, we'll be talking about Charles' law. It's a very easy topic. Now, Charles' law states that the volume of a given mass of a gas is directly proportional to its temperature, provided the pressure remains constant. Now, we have some parameters. Let's highlight them first. Volume. So we highlight volume. Mass. Highlight mass. Temperature and pressure. Now, note that given mass is constant and pressure remains constant. So pressure is constant. So when you have mass constant and pressure constant, then we are talking about you have volume and temperature. You're actually talking about Charles' law. Now let's continue. Now, volume is actually directly proportional to temperature. So we put V directly proportional to what? This is the sign of proportionality to T. Now, if you want to introduce the constant sign, as usual, you introduce the equals to sign, then you now put your K as constant. So you now have V equal to KT. Why? This is the temperature, this is the volume. So let's make this the subject of formula, the K the subject of formula. So I'll have to divide both sides by K. So that's what we have here, V all over. So I have to divide both sides by T. Remember, I want to make K the subject of formula, so I want K to stay alone. So I'll divide this side by T so that this T will be cancelled out. We will have K being alone. So I'll divide this side by T, I'll divide this side by T. So that's what we have here. V all over T, then KT all over T. So this will cancel out this. So we now have V all over T is equals to K, or K is equals to V all over T. So it's the same thing. So if we remember, the form we end this stuff at V all over T. So in some cases you have 2T and 2V, or initial volume as well as final volume, initial temperature as well as final temperature. So we now do it this way: V1 all over T1. Remember, it's actually V all over T, so you decide to equate V all over T1 equals to V2 all over T2. So I've mentioned this before, where V1 is initial volume, T1 is initial temperature, V2 is actually initial final volume, while T2 is the final temperature. So note this. This is a very simple illustration of Charles' law. V is directly proportional to what? T. So in this case, we have when T is small, the low, V is low. But as V increases, T what? Increases. V increases further. V increases further. So this is what proportionality means. It means that one of the parameters is increasing, the other one is increasing. So if something is inversely proportional, it means that as one is increasing, the other one is decreasing. But in this case, in Charles' law, it's directly proportional. It means that as the volume is actually increasing, the temperature is what? Increasing. So it can also be represented in a graphical format like this, where we have the volume. The volume is going up while the temperature is also going up. Remember, this you can try to label this as 1, 2, 3, 4. 1, 2, 3, 4. So realize that as you're going this way, this is also increasing and this is increasing. So this is a graphical representation of Charles' law. You can also represent it. Remember, the temperature here is in Kelvin. The volume here is in meter cube. So let's represent it in degrees Celsius. In degrees Celsius, remember, we'll treat temperature conversion in a separate video. In degrees Celsius, this is how the graph will actually look like. So let's quickly take a look at this question, or a particular example where we can solve using the formula of Charles' law. All right, a given mass of nitrogen gas occupies 0.15 decimeter cube, all right, dm cube at 60 degrees. Remember, mass is constant here. This is what occupied this. So this is V1 at 60 degrees Celsius. So this is T1. Okay, find its volume at the same pressure if the temperature is changed to 100. Remember, the pressure must remain the same. It must be constant. That's the reason why I put the same volume, the same pressure. All right, so you're asked to find the volume at the same, when the pressure is still the same, and the temperature is actually changed to 100. So remember, again, find its volume. What is its volume? When the pressure is the same, and the temperature is changed from 60 to what? 100. So first, V1 is 0.15, which we have there. Then T1 is 60 degree, which we have here. V2 is actually what we are looking for. Find its volume. Then the final temperature is 100 degree. So that's what we have here. So we now have, we'll write our usual formula. V1 is all over T1 equals to V2 all over T2. Now, we are looking for how to make V2 here. V2, the subject of formula. So we'll cross multiply. Use this to multiply this. So now have T1, V2. Then use this to multiply. You now have V1 and T2. So you now have this. Now, how do we make V2 to stay alone? We can now divide both sides by T1. Why are we dividing both sides by T1? Because if you divide this side by T1, T1 will cancel out T1 so that V2 will remain alone. So I'll divide both sides, divide this side by T1. I'll also divide this side by T1. So this will cancel out this. I will now have V2 is equal to this, which we have here. Once you have that, you just simply impute your formula. What is V1? 0.15. You have there. What is T2? 100 degrees Celsius. All over. What is T1? 60 degree. Use this to multiply this. You have 15 all over 60. And if you carry out division, you have 0.5. If you actually, this is 1 here, and this 15 going to this is 4. So if you carry out division, you have 0.25 DMQ as your answer. So it's a very easy thing. In our question and answer video or lesson on Charles Law, we'll take more challenging questions. Thank you.